Hi everyone, in this video I will be explaining you a named theorem that is, it's not a theorem, it's a lemma, that is simple approximation lemma. Okay, so this is a very important lemma that you can see in the second unit of measure and integration. Okay, so here this is the statement. Let me read the statement without further delay. So here they are talking about small f, and they are saying that the small f is a measurable real valued function on the set E. Okay, also they are saying this f is bounded. Okay, and here they are written the condition for bounded. Okay, if this f having these two properties, that is, if this f is a measurable real valued function and also this f is bounded, then the following conditions will be satisfied. That is what we have to prove. The following condition, what is that? Then for each epsilon greater than 0, because you are going to use epsilon, so first you are talking about epsilon. So this epsilon is greater than 0. There exist symbol functions. The symbol functions are what? Pi epsilon and psi epsilon defined on E, and this pi epsilon less than or equal to f less than or equal to psi epsilon. What is mean by this? The f lies between the symbol functions, that is pi epsilon and psi epsilon. Okay, and the second condition is 0 less than or equal to psi epsilon minus pi epsilon less than epsilon on E. Okay, this is what the statement. So here I hope you understood. The only thing you have to keep in your mind is, first you have to keep in your mind that small f, the small f is a real valued function, measurable real valued function on E, and also this f is bounded. If these two conditions are there, then there exists epsilon greater than 0. Sorry, not there exist. For each epsilon greater than 0, there exist symbol functions, this two. Okay, and these two symbol functions will have these two properties. Okay, so that is what we have to prove. So here to prove this, what you are doing is, first you are taking an open bounded interval, that is, let c comma d be a open bounded interval. Okay, and also in the next line what you have to write is, you have to write c comma d contains the image of E, that is f of E. Okay, that is what the second line you are going to write. And the third line what you are doing is, consider you are taking another interval, that is closed interval c comma d, and you are going to partition this interval. Okay, so that you will get like this. Okay, consider, the sentence you have to write is, consider the partition of closed interval c comma d. Okay, write like that, and then write this, put the comma and write this. C is equal to y0 less than y1 less than y2 etc. less than yn minus 1 less than yn equal to d, such that yk, the value of yk minus yk minus 1 less than epsilon for 1 less than or equal to k, that is the value of k lies between 1 and n. Okay, next again you are defining that ik is equal to closed interval yk minus 1 comma yk, and ek is equal to f inverse of ik for 1 less than or equal to k less than or equal to n. So here this here you have an ik, right? This ik is an interval. We know that every interval is measurable. There is a proportion like that. Okay, so you can say this ik is measurable, f is measurable, that is already in the statement. Therefore f inverse of ik is also will be measurable. So if this side is measurable, then ek is also measurable, right? So that is what you have to write. And ck is also measurable. Next, okay, and ck is also measurable. And in the next line you are defining two functions that are pi epsilon and psi epsilon. You are defining like this: pi epsilon of x equal to yk minus 1 and psi epsilon of x equal to yk. So here also pi epsilon is equal to summation k is equal to 1 to n. This yk minus 1 psi of ek, and psi epsilon is equal to, in the place of here you put yk. Okay, that is the only difference you make. Next, let x belongs to E. Okay, we are taking x belongs to E, and since f of E is the subset of C comma D, how you have wrote this? In the first line you have written let C comma D be the open bounded interval, and this C comma D contains the image of E f of E, right? From this line you are using that line here. Okay, f of E subset of C comma D. There is a unique k comma 1 less than or equal to k less than or equal to n, for which some of the words I did not write. The reason is because I don't want to write the whole sentence because this is my notes. Okay, this paper is not my this is what I have prepared. Okay, to make learning easy, I wrote all these things. Okay, f of E subset of open interval C comma D. There is a unique k 1 less than or equal to k less than or equal to n, for which yk minus 1 less than or equal to f of x. You are writing like this. Now from this, in the place of this is yk minus 1, right? In the previous step you wrote yk minus 1 is equal to pi epsilon of x, and can you see that psi epsilon of x equal to yk? So you are applying that here. Okay, that is why this step. And from this you can write pi epsilon of x less than or equal to f of x less than or equal to psi epsilon. So here from this you get this. Now your equation from the equation 1 is subtracted by pi epsilon of x, so that you will get this, and finally you will get the required, you will be proved the required condition in the final. Okay, so here comes the lemma end.